Hi, my name is Elizabeth and today we're going to be going over Charle's law. So Charle's law basically states that if I have a volume divided by a temperature, it's going to equal a constant. So that means any given volume at any given temperature will always equal the same value. The important part of this is an equation that we can get out of it, which is going to be V1 over T1 equals V2 over T2. In your book, it actually states V final over T final. So the final volume over the final temperature is equal to the initial volume over the initial temperature. However, this works as well. So just do whatever you feel comfortable with. So since they're being divided by each other, volume by temperature, we would call this being directly proportional. This means that if volume goes up, so does temperature. If temperature goes down, so does volume. So they're going to be acting in very similar fashions. And that also makes sense, right? If I heat something up, the molecules are going to want to spread out more, increasing the volume. So we want volume to be in liters, and we want temperature to be in Kelvin. So most of the time, your volume or your temperature is going to be given in degrees Celsius. So in order to find Kelvin, that's just going to be your degrees Celsius that they give you plus 273.15, and that would give you Kelvin. They might give it to you in Fahrenheit, and there's an equation in your book to solve for Kelvin and Fahrenheit. In order to do Fahrenheit, you have to convert first to Celsius and then add 273.15, and that'll give you the correct temperature. All right. In this particular equation, it doesn't really matter what your units are, but it's good practice to be putting them into the standard units of liters and Kelvin, because that's going to be useful for when you get to your ideal gas law later down the road. So let's see what this looks like in a problem. So over here I have a problem. It says a tank of oxygen at 21 degrees Celsius has a volume of 785 liters at 1 atmosphere. What is the volume of this container at 28 degrees Celsius? So let's try to figure out what exactly they're asking for, because that's the important part in these questions. In these questions, it's important to know your equations, what they stand for, and how that relates to what you're given. So over here, we see that they give us a temperature. So let's say this is T1. They also give us a volume, V1. And they give us a pressure. And I'm going to highlight that real quick. And I'm going to talk about that in a second. It's asking what is the volume at 28 degrees Celsius. So that's going to be my T2. And I'm solving for V2. Notice they didn't give me a P2. They didn't give me another pressure. So that's how I know that I'm going to use Charle's law, because you can't solve for two unknowns. So you might see T1, V1, P1 and automatically think empirical gas law, combined gas law. But that's not the case here. Just because they didn't give you a second pressure and they're asking for the volume, you can't solve for two unknowns at once. So let's go ahead and plug in those values that they gave us. So first I'm going to convert my T1 to Kelvin. Right, so that's just going to be 21 plus 273.15. That gives me 294.15. And then let's do 28 plus 273.15 as well. And that gives me 301.15. And my volume's in liters, so that works out. Let's go ahead and plug those in. So my V1 is 785. My T1 is 294.15. I'm solving for V2, so that stays there. And then we have 301.15. Another way you can do this in a way that professors actually prefer is to solve for your unknown variable before plugging in numbers. So you can also do that and then plug in numbers. This is just the way I've always done it, but if you feel more comfortable solving for your unknown first, so that means you would multiply by T2. So your equation would look like this instead. So then you can just plug in all your values and solve right off the bat. If that works better for you, feel free to do so, okay? So I'm going to go ahead and finish this up. So I have 785 divided by 294.15. That's going to give me 2.67 is equal to V2 over 301.15. Then I can multiply by 301.15. And that gives me my V2 to be 804 liters. So let's see if that makes sense in accordance to our directly proportional stuff. So here I see that my temperature went up, so I'm suspecting my volume will also go up. And it did. It went from 785 to 804. So that means our answer makes sense. We don't have to go back and make sure that we did everything okay. Since the answer makes sense, it's probably correct. So yeah, to recap, remember that volume and temperature are directly proportional. If one goes up, so does the other. Make sure you have your units correctly. And yeah, that's how you use Charle's law.